Day 91. So today we're going to be talking about solving systems of equations utilizing elimination and substitution. Now, this is an incredibly important skill to have because in the future you may have to solve a system of equations. And you want to make sure that you understand it fully. While you can use your calculator to solve this, this is an excellent skill to have in order to assist you in the future. So try your very best to understand it, okay? I know this is a topic that for most people they find very difficult, and most people also don't get this, but you all are super incredibly smart. So I know you can do this. So let's go ahead and jump in. So the first form, as we've discussed before, is elimination. That's usually the easier one. Substitution usually involves way more steps, okay? So typically for elimination, we want to have them written in standard form. And we want the coefficients of either x or y to match as a zero pair, meaning same number, different signs. And of course, in order to achieve that, we just multiply coefficients until they make my zero pair. Now, that's not the most important part. The most important part is actually looking at the equation. So, I'm going to look at this. And it's already written in standard form. So that makes it a little bit easier. You don't necessarily have to do elimination in standard form. It's just much easier if you do. Okay? So I look at the numbers that are attached to my x, 5 and 10. And I look at the numbers that are attached to my y, 1, -7. So I'm going to write this out the long way just to give you guys a little bit of understanding. But this is essentially the process that you should go through. 5, 10, 15, 20, 10, 20, 30, 40. So we think about all the multiples. And for 5 and 10, I see that the only thing they have in common, the lowest one, is a 10. Meaning my 10 is already there, and my 5 needs to get multiplied by 2 to get there. Okay, pretty simple. Now I compare my 1 and my 7, and I see that the very first one they have in common is 7, meaning this guy's already here, and this whole equation needs to be multiplied by 7. I would rather multiply by a 2 than a 7, because I don't want to start creating all these gigantic numbers. So I'm going to go ahead and I'm going to multiply by 2. Now, that's what I was saying when I say compare the numbers, okay? So I'm not going to do this for every problem, but this is the thought process behind it. So I'm going to go ahead and I'm going to take that first equation. And I'm going to go ahead and multiply it by 2. Okay, now I have my equation multiplied by 2. Excuse me, it should have been -2 because we want to make 0 pairs. And now I'm going to go through and I'm going to add together both equations. The x's, y's, numbers. Now, that's the reason why we want it in standard form. You could, like let's say for example this y was over here. Yes, it would still just add forth and drop down, and it would combine with any like terms, but it would not combine with anything that isn't alike. Okay? So here I see this 10s are going to cancel. And I end up with this. Now I can go ahead and divide by -9, and I end up with the y solution of y equals 4. Now I'm going to take that, and I'm going to plug it into either one of my original equations. Never, ever, never, ever, 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 never, ever, ever, ever plug it into the one that you made. The reason is the numbers are going to be larger, it's going to be more difficult to work with, and you may have made an error with your math. Okay, so you always want to make sure that you plug it into one of the original ones. I'm going to choose the easier one, this guy. So 5x plus 4 equals 9. Noticing we substituted y for 4. So I'm going to go ahead and I'm going to move that 4 over. I'm going to do my exciting move. Great divide. And I end up with an answer of x equals 1. So my point for this one is that this is consistent independent with the solution located at 1, 4. These should be two lines crossing over that intersect at one point. So I'm going to go ahead and I'm going to verify my answer with my calculator. I'm going to head on to the home screen, add a new calculator page, and I'm going to start a new solve system of linear equations that will give me this LinSolve. I'm going to type in both original equations. And this should give me the exact same answer. It did. I did this correctly. And I can keep going. All right. So let's go ahead and look at the next one. So here I look at these and I say 2 and 3, 7 and 5. These guys have 35 in common. So that's a lot. This is 6. So I'm going to go ahead and I'm going to multiply one of these. I'm going to go ahead and multiply this one because it's smaller numbers. So I'll multiply this guy first by -3, and then I'm going to multiply this guy by +2. All right, now I have two equations that I can combine. Cancel. And I'm really close, except my y is negative. So let's go ahead and divide everything we see by -1. And I end up with an answer of y equals 5. Now I want to take that, plug it back into one of my original equations. I'll choose this one because it has smaller numbers, okay? So 2x plus 5 times 4 equals 14. So I'll go ahead and continue to simplify. I'll do my exciting move. Great divide. And look at that. I ended up at x equals -3. That means that this guy is a consistent independent with a solution located at -3, 4. Let's verify that with our calculator. So I'm going to go ahead and start another LinSolve. And for this one, I'm going to go ahead and type in my original equations. And it looks like I got exactly the same answer. So I got this one correct as well. Now, what about that substitution? So one of the equations must be solved for either x or y, meaning we got it by itself. So I have y equals everything else or x equals everything else. This is called isolated. This is an example of solving for. So when people tell you solve for x in this equation, they're asking you to get x equals everything else. When they say solve for r, they're asking you to get r equals everything else. Even if that everything else happens to be a number or happens to be some other set of variables, it is still the same exact concept. You're still adding, subtracting, multiplying, dividing in order to get the variable by itself. So let's take a look at this one. Here they're asking me to plug in x equals 2y plus 10. What does that mean? Well, that means that this, and this are all exactly the same. So depending on my situation, I can choose which one of those I want to use. Because I do not know how to solve an equation that has two variables in it and get both answers at the same time, I want to make one where my equation only has one of the variables. So I look at this and I say, all right, this one has a y, and they told me what x is, so I can change out x with this. So I'm going to take that initial equation, 6x, I'm going to replace my x with 2y plus 10 and copy down the remainder of the equation. Now I'm going to go ahead and attempt to solve this. I'm going to distribute. I'm going to combine like terms. I'm going to do an exciting move. And, of course, a great divide. I end up with an answer of y equals 4. So now I can go ahead and take that and I can plug it back into whichever one I want. Luckily, they already substituted. So if I plug in y here, I already have x solved for. So x equals 2 times negative 4 plus 10. I'm going to go ahead and continue to simplify this. And I end up with an answer of x equals 2. That means this is a consistent independent located at 2, negative 4. Now I'm going to go ahead and I'm going to verify my answer in the calculator. I'm going to start another LinSolve. I'm going to go ahead and type in my equations exactly as they appear in the problem. And I received the exact same answer, so I got that one correct. So let's take a look at that very last one. Now, for this particular one, they told me that y is the same thing as that, and it's also the same thing as that. So I can switch around any way that I want to. So what I'm going to do is I'm going to take this x containing portion, and replace that y to get an equation where I have something I can solve for x's. Because if I replace this with a y, I get y equals y. I won't have an answer. So let's go ahead and do that. X plus 3 equals 2x plus 5. Oh, backwards. Sorry, guys. I'm going to collect all my x's together. I'm going to do my exciting move. And no great divide here. I'm done. I found my x. Now I'm going to plug it back into the easier one. I found my solution. This is a consistent independent located at negative 2, positive 1. Let me verify this with my calculator on a LinSolve. So I'm going to type in those two original equations. And I got exactly the same answer. So I know that this could be a very confusing process, so this is going to be a slightly extended video. I'm going to go ahead and I'm going to work through a few other problems. So here's a slightly more simple substitution problem. Now, for this particular problem, they told me that y is equal to 4x, meaning this, and this are all the same. So I can choose to plug in a 4x as opposed to a y. I'm going to go ahead and do that. Now I have an equation where I can solve for x. I'm going to go ahead and reduce it, get rid of that coefficient, and I end up at x equals negative 1. So now I'm going to take that and I'm going to plug it back into the easiest equation. I choose this one because I am looking for y. I find out that y is equal to negative 4. This is a consistent independent located at negative 1 comma 4. And I utilized substitution. All right, let's try one more substitution. So here they told me x to y are the same. So I can choose to get rid of that x and replace it with a 2y. I'm going to go ahead and do so. Now I'm going to go ahead and gather all of my y's together. I'm going to do a great divide in order to get rid of that coefficient. And I end up with y equals 2. So now I'm going to go ahead and I'm going to plug that back into the easiest equation in order to solve for x. And I find out that x equals 4. This is a consistent independent located at 4 comma 2. Let me just verify that with my calculator. Yes, exactly what I found earlier. Now I'm going to go ahead and I'm going to go back because I don't think I verified this guy. But let me go ahead and just plug this one in anyways. So I'll go ahead and do another LinSolve. And yes, of course, I got the same exact answer. All right. So now let's go ahead and let's take a look at a elimination problem. So here I'm looking at my two x's. I see they have a 3 in common. Here I see they have 4 in common. I would have to multiply by 3 in order to get rid of an x, or multiply by 2 in order to get rid of a y. I'd rather do the 2 because it's easier. So I'll go ahead and multiply this guy by negative 2. And I'm going to go ahead and copy down my second equation. Now I can go ahead and add them together. Oh, and look at that. Magical. We already have a solution for x. Now I can take it, plug it back into either one of my original equations. I'm choosing the very first one because it is easier to solve. So 4 plus 2y equals 0. Let's go ahead and do an exciting move. Great divide. This is a consistent independent located at 4, negative 2. Let's verify this with our calculator. And I got the exact same answer. So I got this one correct. So let's try another one, another elimination. I'm looking at these, and I see here that I have 3 in common, so I'd have to multiply by 3. And up here I have 10, which means I'd have to multiply both equations. This one by 5, this one by 2. I don't want to do all those extra steps, so I'll choose the 3. I'll multiply my top equation by negative 3. And I'll go ahead and carry over my bottom equation. Now I'm going to go ahead and add them together. My x's will cancel. And I end up with this. I just need to divide in order to get rid of that coefficient. I find out that y is equal to 3. I'm going to plug it back into the easier equation. I'm going to continue to solve. And I received a response of 7, 3 for a consistent independent. Let's verify that with our calculator. And I got the same exact answer, which means I got this one correct. Now, what about those consistent dependent? Well, these are those guys that have infinite solutions, all real numbers, true, consistent dependent. And they're also, if we were to just look at them, the same exact equation, meaning they touch at every single point. So I'm looking at this and I'm saying, all right, what can I possibly do with this? Well, let me go ahead and move. I'm going to take that first equation. I'm going to rearrange it just a little bit. I'm going to move that 6a over. And I'm looking at these two equations now in comparison to each other. And I see that I can eliminate this bottom a by multiplying it by -2. I could, conversely, divide the entire top part by +2 if I wanted to, okay? But we'll stick with multiplying. I'll multiply by -2. And I'm going to go ahead and copy over my top equation. Sorry, guys, made a mistake here. It wasn't -2. It should have been +2. So let me go ahead and head back a little. There we go. All right, so I'm going to copy that top equation over. And over here, I'm going to write down what I get after multiplying by +2. So cancel, cancel, cancel. Okay. I'm left with 0 equals 0, a true statement. This is the same thing as getting the letter C in my calculator. This tells me infinite, all real numbers, true, same equation. Okay, let's verify this with the calculator. Now, hold on, let me start this over. So let's imagine that I really wanted to be super crazy, right? And I wanted to use the same exact variables that they did. I could go here and change them. You don't have to, but just remember to keep consistent what you call X, what you call Y, all right? And it's going to give me a letter C, telling me that these are correctly the same exact equation. And that means that I got this correct because I got a true statement. Now, here's another one. I'm going to go ahead and I'm going to multiply this top one by -2 in order to get my zero pair. I'm going to copy down the second one. Cancel, cancel, cancel. I got 0 equals 0. This is a consistent dependent. Let's verify that in the calculator, though. And look at that. I got a letter C in there, which tells me that this is definitely a consistent dependent. Now, what about these inconsistent guys? The ones that do not make any sense. Okay? So, inconsistent is the same thing as saying false, no solution. This will be given to us by the calculator as no solution. Okay? So, here I'm going to use substitution. Or I could go ahead and I could also use I could go ahead and use elimination if I wanted to as well. So I'm going to go ahead and I'm just going to multiply this bottom one by -1. I end up, after I copy this top one, with this. I'm going to go ahead and now combine these. Notice how I don't necessarily have to be in standard form. Okay, let me simplify that even more. And I end up with something crazy. A false answer. This means that these are parallel lines. They will never, ever, 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 ever touch. Also called inconsistent. Okay, let's verify this in the calculator. So here it should spit back a response of no solution. No solution found. Exactly what I found as well. All right, last example. Here is my other inconsistent one. So I look at this and I'm like, all right, let me go ahead and just rearrange this. I'll move this 2/3 x over. Okay. And let me go ahead and multiply everything by a 3 to get rid of that fraction. Okay. So now I have this. I'm going to copy my first original equation over again. I'm looking at these. Okay, good. The x's will cancel. So cancel, cancel. 0 equals -6. Another false one. This is an inconsistent. No solution. So let's verify this with my calculator. No solution found. Exactly what I found as well. So I thank you guys for sticking with me through all this time. Go ahead and get started on this example problem. Feel free to use your calculator, but at least attempt a few of them using either substitution or elimination. I'll see you guys next time.